Hey everyone, it's Mukhtar here, the math expert. Right, so we've got a question in front of us, and it's actually to do with integration factor. Plus 5y equals ln of x divided by x. Brilliant. So first things first, we actually need to understand how the integration factor looks, right? There's a specific way you've got to design your differential equation for the integration factor to work. And it looks like this, right? So integration factor, it's meant to be in the form of dy dx plus p of x times y equals q of x, right? And it's a situation where p of x and q of x, right, are functions of x. I'm just going to write that down. Functions of x or constants. If your equation looks like that, then the integration factor will pretty much work every time. Okay? Now, let's get back into it. So I'm going to redesign our equation as that. So I'm redesigning our equation as dy over dx. I'm going to divide through by x. So it's going to be 5 over x, y equals ln of x divided by x squared. I hope you're still with me by now, right? Now, this is another thing. We're going to swap back into the integration factor. How do we actually solve it? Well, you need to know what the integration factor is. Super important. The integration factor, I'll call it IF, is actually e to the power of p of x, of the integral of p of x even. E to the power of the integral of p of x. So that's taking the exponential of the integral of px. That's all it is. Okay? So for this specific question, I'm going to try and figure out our integration factor. And I know p of x in our question is 5 over x, right? So I'm going to just make a little note over here. P of x in our question is 5x to the minus 1 or 5 over x. You can clearly see that from the question. So what am I going to do? I'm going to do the integral of 5x to the minus 1 respect to dx. Okay? I know that's going to be the integral of ln of x, ln of 5 ln x even. Okay? Well, I'm going to rearrange that using our logarithm rules, and that's going to give us e ln of x to the 5. Again, that's a log rule I've used there. If you don't know that, do look back at that. Okay? And then because e and ln cancel out, that integration factor for our question is x to the 5. Right, we're almost there. However, there's something more that you need to know. And this is where it gets really, really, really interesting. Some super clever guy a while ago, I don't know how that person figured it. I don't know how much time they spent figuring it out, but I'm going to show you what they figured out. They figured out that, well, I'm going to do this in actually a slightly different color now, is they figured out that if you multiply through by the integral of p of x, I'm not going to write the dx there just because I want to save time, through by the integration factor question, right? So we multiply through by e of p of x, okay? They figured something really, 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 really brilliant out. I'm going to just write it out first. And then equals q of x. Sorry, I'm just going to put this on the other side. Hope type A is okay with that. They figured out that this is the same thing as the chain rule of e of p of x of y. Okay? So they figured out that this entire left-hand side of the equation is the same as this. And that's where the integration factor becomes super important. They realized that, try it. Like, if we use the actual product rule on this, the product rule on this differential, you're going to get this above here. If you don't believe me, try it. Okay? You know what? Let's do it now. We might as well. We have a little bit of time. I'm going to go for a slightly different color again, guys. Sorry I'm using so many colors. But if you actually look at it, I'm going to put in a little box over here, right? If you had e to the integral of p of x times y. Oh, No, actually, we're not going to do it. No, we're not going to do it. I'm going to delete that. We're not doing that bit. I'm going to delete that. Okay, so that's what they figured out. And once you know that, well, we can actually move on with the question. Okay, so I'm going to simply apply it to our own question. Okay, so first things first, I'm going to multiply through, right? So multiply through by the integration factor. And in our case, that's x to the 5. So it's x to the 5 times dy over dx plus, that's going to give us 5x4 times y equals x cubed ln x. Brilliant. Okay? And then remember what we just said on that bit. Well, we know that if we do the reverse product rule here, we're going to get d, the integration factor, in our case x of I, times y, I'll put a dot in the middle to separate them, dy, would equal x3 ln of x. And that's what you need to know. And here we're going to actually just quickly to the side in blue again, we're going to go look to make sure it's the same, right? We're going to make sure that this left-hand side equals each other, right? And we're just going to check it over here, right? So if we had x to the 5 and y, and we labeled one u, we labeled the other v, right? We know the product rule, right? If we want to do the differential of that, it's going to be 5x to the 4 times y plus the differential, which is dy over dx of y times x to the 5. Of course it's the same. Yeah? And all I've done there is differentiate that, okay? I've differentiated that to show you that it's the same. All right? Now let's get back to the main question. Now that we're confident it's the same. Well, I made a mistake just there, guys. I made a mistake just there. Sorry about that, guys. Thank God I found it, corrected it. It's over dx. All right? Because we're just differentiating that. Cool. Now back to it. So, I'm human. X to the 5 dx. I'm going to integrate that side. And I'm going to also integrate this side. I'm just zoom out a little bit just so we have full scope of the work we're doing, right? On this side, it's simply just going to become x to the 5 dot y, right? And then on this side, well, that is going to look like we're going to have to do integration by parts. So I'm just going to get straight into it if that's okay, right? I'm going to use u as ln x because then du over dx quickly becomes 1 over x. I'm going to use dv over dx as x cubed, and I'm going to use v as x to the 4 over 4, right? We know the equation is going to be u times v, so that's going to be ln x times x4 over 4. Take away v x to the 4, v times d over dx, 1 over x, right, to dx, right? If we do some integration work there, that's going to quickly become, over there, that's x cubed. Guys, I'm going to do that bit in one if that's all right. Please keep up if you haven't. X4 over 16. And then that's done. So I'm just going to have plus c, and I'm going to bring back this. Okay? Right? I did some integration there. Take your time to do the integration further if you couldn't keep up with that. Right. So what do we do now? Well, I'm simply just going to divide through by x to the 5. And that's actually just going to give me ln of x over 4x minus, well, that'll give me 1 over 16x plus c over x5. That's the answer. Well, that's the question. So, just to go through it one more time, make sure you take your steps with integration factor. Understand when we're doing the reverse chain rule, product rule, whatever you call it. And then you'll be able to do the integration factor questions. I hope that makes any sense. Please leave pointers in the comments if you have any issues, qualms, or queries, and I'll make sure to answer it. Okay? Thank you very much.